Okay, it's time. Welcome, all of you here, to this session that is about moving a multidimensional cube, an SSA's cube, from or over to Tabular. I would like to start first. I can present myself here. This is what have I done before. I worked a lot with SQL Server, all the versions of SQL Server 7, but mainly with BI. So the other part of SQL Server consultants are the DBAs and developers, like some people here, that work more with transaction systems and things like that. But I have worked with the BI part since SQL Server 7. And I like to play golf. And I live here in next to Copenhagen in a small city called Malmö. And the king of Malmö and the king of Sweden is Zlatan Ibrahimovic. So you know where that spot is probably. I built some tabular models before. One was proof of concept for a big insurance company. We actually loaded that one. That was big. 200 gigabytes of data in the data source. And when we loaded it into Tabular, the model was around 25 to 30 gigabytes, so the compression was quite good. When that data file is loaded into memory, you can actually count with around 2 to 2.5 the size of that one on disk. So you need quite a good server, big server with a lot of RAM to run that model. And that model did execute with the queries instantly. So that was quite interesting. The other one I worked with was for a hotel chain, and that was much smaller, and that was 1 year ago. Yes? Let's start first. This is actually about a real customer case, and I will come to that in the next steps here. But I think there are a lot of unclear ideas about the technologies involved here. First, I would like to start with your background here. How many of you are more DBAs or developers? You don't work with the BI at all? Anyone here? Okay. How many of you are BI developers? Yeah, okay. And how many of you work in an ET department supporting IT solutions? Or BI solutions? Okay, a few of you. Yeah, good. Yeah. Then I know most of you know what a multidimensional model is. How many have worked with a multidimensional? Okay. And how many have worked with Tabular? Okay, a few of you. That's why you're here. Probably. Yeah. And the thing is that, sometimes they say that, or part of the tabular model is column store indexes, and column store indexes are also part of the SQL Server relational engine since 2012. But the important thing here is that columns, the only part that has gone over to the relational engines are the indexes, nothing else. The query engine in the relational engine is still the same as before. So then we have BILS multidimensional or SSAS, and we had the BIS tabular. They actually added those names in 2012. And BIS stands for Business Intelligence Semantic Model. And before that, SSAS was called UDM, Unified Dimensional Model. So marketing make them change the names all the time here. But on the server side also, we have Power Pivot for SharePoint on premises. This is actually a service running in SharePoint. So you can actually have the technology there as well. And you can have Power BI, the technology running in the Power BI portal as well. So this technology that is part of BIS Tabular and Power Pivot and Power BI, they are the same, more or less. Column store indexes, compressions, and other stuff. But the engine is complete with those clients, so to say, or with those servers here. And on the client side, you have Excel 2013 on premises, where you can actually build a model. column store indexes, and yeah, the VertiPack engine or Power Pivot. It's actually Power Pivot there as well. And you have Excel 2013 Click to Run. That's the Power BI version of Excel. So the Excel 2013 on-premises version is one that gets new releases each second or third year, something like that. And the Click to Run, for the Click to Run, Microsoft add features all the time. So during, yeah, every second month or so. And the new one is in the family is the Power BI Designer. And it also uses a Power Pivot model behind the scenes there. Any questions so far? I'm going to focus on the ones in blue here. So let's leave the others. My previous ideas about Tabular and multidimensional, before I started to work with Tabular, was that maybe, okay, this sounds good. Everything is loaded into memory. Memory is closer to the CPU, and it must be faster. And I've seen all the fancy demos from Microsoft also, where they sort, 1 billion rows or things like that. So it looked very good. But the thing is that the interesting part is how can we use it for the customer? When is it interesting to use at customers and make some benefits of that? The customer assignment, this is a medium-sized manufacturing company in Sweden. They have used multidimensional models for a long time, 10 years, something like that. But now they wanted to build a consolidated purchase model, and they decided that they wanted to go from multidimensional to tabular. And I got a comment from Marco Russo, he's not here yesterday, and he said, why would anyone do that? And this customer actually did it. So the important thing here was that in this project, I was a mentor to a new guy that they have employed in this company, and they wanted him to learn tabular first before learning multidimensional. So that's the reason. They could actually copy multidimensional cubes and just made some changes to that and have a solution up and running in quite a short time. Yeah. And they have a dedicated server for Tabular, so there is no problem with running both multidimensional and Tabular on the same box. That could be a little bit tricky because they have very different models. Tabular takes all memory that you can get, and the other model is more disk-based and more cleans up memory all the time here. So how do you work with an assignment like this? Well, first we had to find out the features in multidimensional that are not part of Tabular. You can actually find that in books, or you can go to websites and check. I have not seen that good or clear reporting from Microsoft, but actually Marco and Alberto and Chris Webb's book about BISP Tabular has a small chapter about that. So most of that, what I have found, has come from that book. What we have to do next is to identify the multidimensional features that are actually used with this customer cube. So even if there are a lot of features in multidimensional, normally not all of them are used here. And then we have to identify all the multidimensional business logic, and that is MDX, but it can also be other parts of the cube. We have data source views. Well, actually, there are some implementations where developers have put in a lot of logic into the data source views. And when we have done that, we started to build a view layer because there are no data source views in Tabular. And we need to run some quality checks here to see that all the keys were accurate and that all data related in those models. And that was, that took some time because they have separated their cubes, so each internal company have their own cube and their own data warehouse. So that it can be up to 20, something like that, different data sources here. And after that, we started to build the tabular model, and added the business logic in DAX as the last step. And after that, it was the boring part. It's testing and see and pray to God that all figures were the same as in the sources. And they actually did match. So we were lucky there at the first attempt. So this was because we did put a lot of work into to checking that all data was correct. The other approach is actually not to care about that until you load a model, and you get a lot of errors coming up when you process the tabular model. Okay, how do tabular and multidimensional work? Yeah, multidimensional is the old technology. It came out on the market in 1999. It was called OLAP services in the first release. It's actually disk-based. So everything there, all data has a row-based storage on disk. Everything has to be called from the disk and then loaded up to memory. But it has a very conservative model for memory, loading things into memory. So it actually has cleaner threads going around all the time, just checking by time how much of this data has been used during the last 10 seconds, 100 seconds, things like that. You have settings for all this. And the MDX concept, when you build a cube, it's a multidimensional space. You have more to think about. You have dimension, attributes, hierarchies, and measures. So there are more objects to think about. Tabular, on the other side, the whole model, when a client calls it, or if you open up Management Studio the first time, all the models that you have on that server that you look at in Management Studio will be loaded directly into the server memory. Yeah. But if a client opens up a connection to a single database, only that will be loaded into the tabular. And it will stay there until you do something like processing the model again. So it's stuck in memory. And the benefit of that is that if other users call the same cube, it's there. It does not have to be loaded from the disk system here. And it's a column-based storage. And there is nothing like complex aggregations, things like that. It's more simple. And in the world of DAX, that's a problem for some people here, going from MDX or SQL to DAX. There is only tables and columns. That's the whole thing. It's a two-dimensional model. And the features in multidimensional that are not directly supported in Tabular. Write back is a tricky feature. Some customers use it, but it's not that frequent. It's very tricky. You need to know your stuff if you want to try to implement that. It's usually used for budgeting. You want to write some budget measures into the cube, and it will go down to a summary table in the relational source. Translations is a feature that you can add other column names in different languages in the model. Actually, Tabular has prepared to some extent for that, so you can actually add it, not from data tools, but from another tool called Bids Helper. So, and this is a Codeplex application that you can download and then add translations in that way. Dimension security on measures, it's not implemented at all in Tabular, so that can be a showstopper if you have some, really business critical measures, like I've seen in other organizations. Cell security is the same. That one is tricky, multidimensional. It will make your multidimensional cube perform very badly. RAG hierarchies, that's hierarchies that don't have the same number of levels going down, like, states in the United States, you have USA, you have the states, and then you have the city. We don't have a concept like that in Sweden. We have another organization, and I think in Denmark as well. Parent-child hierarchies, or no, more role-playing dimensions, but that is not an issue. You can actually duplicate views to get the same behavior. MDX scoped assignments and unary operator, they cannot be moved to Tabular at all, because Tabular has no vision about coordinates and multidimensional space at all. It's just flat. Parent-child hierarchies, you can actually, Marco and Alberto, they have examples on their sites where you can get DAX code to support that feature. Many-to-many relations also can be supported by DAX, but there's no interface for that. In multidimensional, you have that. And cube actions and display folders, the two last ones, can actually be implemented with bits helper as well. They are not part of the data tools. Okay? Possible issues then. Recreate business logic. Moving MDX business logic from multidimensional to tabular can be tricky. If you have simple measures, that's not tricky at all. I will show that at the end of the presentation. But you can have, it's those script assignments where you do allocations of measures and things like that don't have the same in Tabular at all. Multidimensional features not supported in Tabular. I mentioned that in the frequent slide there. And another one is report hierarchies. If you go to Tim Peterson's session, Tim is here. He will talk about that. It's not possible at all to do that in Tabular. So that's actually a way to reduce the number of measures, calculated measures in a cube by implementing a calculation hierarchy outside of normal hierarchies. Composite keys, this is important as well. In multidimensional, you can, for each dimension, you can add more than one column for the attribute to work if it's not unique, if you don't have a unique combination or a unique single key. You can actually try to make it unique by adding 2 columns or 3 columns. And in Tabular, you can only join on 1 column. It's not possible to, like in the relational world, to join on several columns here. There is also a model difference. In multidimensional, you have databases. You have that as well in Tabular. But on the model level, the next level, you can have many cubes. You can have many multidimensional cubes. But in Tabular, you can only have 1 tabular model per database. So if you have a multidimensional model with several cubes in the same database, you will have a problem. You will have to force all those cubes or the measure groups into the same tabular model. So you cannot call another tabular model from another tabular model. And but if you go down to the fact table level, it's the same between both. A single cube can have many fact tables. A single tabular model can have many fact tables as well. And then we have features that exist on both platforms, but they are not the same. Partitions is a way in multidimensional to some extent increase or performance tune queries. You can actually have some doubts if it really works unless you have a cube with around 500 million fact records or something like that. Before that, it creates too much overhead. In Tabular, it's simple. You only use partitions to load data into the model. And that's when you have big tables that you cannot load directly in one batch. And security was mentioned before. Drill-through is also a thing that is more extended in the multidimensional model than in Tabular. But Built Helper have some extensions to that you can use. Tabular improvements. This is the last slide before demo. Tabular improvements over multidimensional. There are no attribute relations. That's the tricky part with building a multidimensional model. Attribute relations. You cannot just build hierarchies. You need to tell how they relate also before you can build a hierarchy. If you don't add attribute relations, I've seen some customers that have not, you will not have good indexes in the multidimensional cubes, and you can actually get wrong answers back as well. So this has been an important feature to add to multidimensional cubes, and it has been a little bit tricky. That concept does not exist at all in Tabular. There are no aggregations in Tabular, so you don't have to call in a multidimensional expert to analyze your cube and look for possible aggregations. There are no aggregations at all. It's only the indexes, the column store indexes. Distinct count, that's a beauty. I will talk about that later. Distinct count in multidimensional, you have to have a separate measure group for that, and it takes a long time to process. In Tabular, you actually create your distinct count with DAX directly, and it's fast. It's really fast. And that's one of the best things with Tabular, actually. Query speed for smaller models, you will actually need to run some tests for that. But since multidimensional is loaded from disk, and some of that data is cached into memory, it's probably the Tabular model have some better starts, how to say, it's a little bit easier for Tabular to get the data quicker because it's resides in memory. It's not on disk. Faster load time of the model as well, because we don't have aggregations at all. The other one is that you can prototype in Excel. Actually, you can use the Excel pivot tables, build a model in there, add DAX to that model, and later on, when you're finished with that model, you can put that to your IT department, and they can deploy it on Tabular. Actually, if you have gone to the Pyramid Analytics booth and checked their software, they have been here during all the days here. They actually show you they have an implementation where you can build a local power pivot model in their client and actually deploy that directly in Tabular. That's not possible with Excel. You need to give them the model, and they need to import it before deploying it on Tabular. And one thing is also that you can process a single object. If you run full process on a dimension in multidimensional, what happens? It invalidates the whole model. Yeah, you have to process everything. Here you can actually process a single table, and the rest will work. So now it's demo time here. How do we check that what business logic that is part of the multidimensional model? Any tips here? You can see something up there. Okay, let's go to the demo. Yes, we can actually use this. Beautiful things here. This is a data management view of the cubes. So I can actually run queries like this. And this first one is to get to the calculated measures and the definitions of them. If I'm not correct, have a look here. Dim key, dim. No. That's the other one here. It's the. Let's run this one. I will give you all those scripts later on. I was actually going down to the dimension usage tab. This is the one for calculated measures. So here is the expression. And what you can do then is to actually just copy it, paste it into Excel. And then you have a list of all the objects in the multidimensional cube that are calculations. The other one is this one here, dimension usage. That was actually the one that I had executed here before. What do I get here? I get actually the relations between each dimension and each fact table with the keys. And I can copy and paste that into Excel as well. So if we continue down here, you can see we also have for hierarchies, like this. The hard way is actually to visually inspect everything in data tools and just write it down. But this one is quite quicker, I think. But this is how we did it at this company. And here is the cube, the database cube, and the dimensions as well. So here are a lot of interesting things to get. One thing is not possible to query with this method. What is that? Anyone? No. Data source views. You have to write an application that uses AMO to get at that. Unfortunately, I don't have an example with me, but there are examples on the web that you can add. I don't know why they have not implemented data management views for that, because it would be very good to have it. Normally, most customers do not have logic in the data source views in the cube, because it's very stupid. It's much better to have it in the views instead, in the relational data source, because then you can change it all the time. So this was the first part here of the demo. There are things, I see here, there are things that we are not interested in. And what is that? What can we not port to Tabular? Security, to some extent, can be if it's simple security, like, you have company security. Yeah, that can be ported. But it's actually name sets, you know them? You don't have that in Tabular. And script assignments, like we said before. They are not in Tabular at all. So actually, we can retrieve that information, but we don't care about it because we cannot do anything about it. So we don't have name sets at all. So let's go back to the customer. What happened here? Yeah. Now it's time to figure out if it's possible to move the model over from multidimensional to Tabular. And the things that made it possible here was that they had a limited number of meshes. If you have a multidimensional cube with hundreds of meshes, you don't want to sit in data tools and implement each of those meshes in that tool, because the designer there is horrible for DAX queries. One way to do it a little bit more efficient is to actually build an Excel model first, because the DAX editor in Excel is much better than the one in data tools. Time calculations, there was a limited number of time calculations, and DAX have, like I will show you, a lot of the same time calculation or time intelligence logic as multidimensional. And there was no script assignments at all, no many-to-many relations, no parent-child hierarchies. It was a small cube with 4 fact tables, not much data, and 18 dimensions. And the security model was simple. It was only, this is a consolidated purchase cube, so they should be able to see everything. So security was not an issue here at all. So this was, a go for moving everything over to Tabular. Last week they asked me about moving another cube over to Tabular, a sales cube, with a lot of measures, calculated measures, script assignments. And we decided not to do that, just to upgrade it to SSAS 2012 in order to use PowerView multidimensional from SharePoint, to be able to make PowerView reports on top of multidimensional models. The product guidelines here. No manipulation of data in the Tabular model. This is very important. If you add row-by-row calculations in DAX, in Tabular models, that is slow, really slow. So do as much as possible out in the viewer, in the view layer. That's much better. The only exception here that I will show also in the demo is hierarchies of a Snowflake dimension. We actually use DAX to implement that. And do the quality checks before. That's my way of doing it, to secure that nothing happens when you process. Other ones, they work very quickly and find out that they have problem when they try to process. what can happen is that if you have fact records in Tabular that are missing, that have dimension keys that are not part of dimension, that is not an issue here, because they will be added to a null member in that dimension. But if you have duplicates down in Tabular, then you can have some issues. Or you have duplicates up in the dimension. That can be an issue. And then it will stop. And there were also currency conversions, and they were simple. They have one local currency, and they had a common currency that was Swedish kronas that they used for an entire company. So we actually pre-calculated those in the views as well. The nice thing is if you can have dynamic calculation of currency, then some finance departments find that interesting, so they can model and check effects of currency changes. But this was not the fact here. And the old rules of multidimensional still apply in Tabular. It's be careful with strings. Don't load strings. Not too many of them. If you use strings, use short strings. Yeah. And you probably know as well that you need, the good thing for Tabular is if you have attributes, like on customers, like gender. You can only have 2 values for gender in the customer dimension unless it is a company. But then you can reduce and use the column store column store indexes more efficient if you have attributes like that. If you have highly selective attributes, that's not good, like a personal social security number, things like that. So nothing has changed there. Okay. Demo number 2, hierarchies on Snowflake dimensions. I will show this slide first here. This is actually from the Adventure Work Tabular Cube project that you can download from Codeplex as well, if you would like. Just add it on top. So here we actually have a Snowflake product dimension here. We have product here. In the middle, we have product subcategory and product category at the top. And the thing is here that one way to solve this is actually to build a view, so you have one table. But we did not choose to do that because it looked like this in a multidimensional dimension as well. So we did not want to confuse the users. So we decided to add calculated columns here, like you can see, product subcategory name and product category name into the product table by using DAX. And this is how it looks. This is the real. Let's go here, have a look. And this is product here. And let's go out to the right. Be careful when you have a look at this, because not all products have product subcategories and categories. So if I go out here, you can actually see the DAX here at the top here. That one. This is an example that is mentioned in the book by Marco, Chris Webb, and Alberto as well. Actually taking it from there. So you add a function called related here to get the subcategory and category values from the 2 other tables. But the simple way is build a view. But this was a little issue in this project. We did not have that many issues, actually. Settings to be added to the tabular model. This is also quite important. It's to help Power View with metadata, and it's also to help other clients with extended metadata as well. So you have table behavior properties. These are more clear if you build them in Power Pivot in Excel. They are more clear, they have a better user interface. But they might be important, and they are here. Have a look here. They are actually hidden. Let's see. Properties is there. They are actually here. These are the ones here. you really have to look careful to see them. If you don't use them, you can have some strange things. You know, with a customer with a first name, last name, you can have several customers with the same first name, last name, but they have a separate customer IDs. And you can control the behavior that they will show, even if they as two separate records, even if they have two different names, or two exactly the same names. So it's properties like this you have to set here on each table. Okay. Tabular security is another thing here. It's you don't have any deny or revoke permissions in this world. So if a single person belongs to two roles, different roles with different permissions, what will happen? If they are contradictory, like say I have the right to see Sweden and Denmark in one role and Norway in another role. Will a Sweden-Denmark role deny me permissions to see the Norwegian? No, I will get everything. Yeah, it is as simple as that. And you can also see here, I actually created a small cube just to illustrate the security. The security, you create roles here, and you add, sorry, go up again. And you add the the DAX here. I have 3 companies here, one called C1, C2, C3, and you actually write the expression like that one. It's not difficult. So this is the way to do it. If you have more complex security scenarios, then probably stay with multidimensional. Okay, available free tools for Tabular. Actually, my mind came to, or I actually saw part of those tools after we finished the project. But let's have a look. We have a DAX editor that is a Microsoft Visual Studio add-in. If you download that from Codeplex, you can actually write your DAX measures in Visual Studio. So you don't have to use the horrible writer or a DAX writer in data tools. So that can help you. It's not supported by Microsoft, it's done by other consultants. But have a look there. You can author calculations there in a single script view, like you can do in the cubes. DAX Studio, I will show that. Oh no, I will show bits helper. DAX Studio is also an important tool. If you would like to write DAX queries that returns tables to you, so you can check measures and things like that, then it's a very helpful tool. You can also do query tuning, because it supports query plans, DAX query plans. You can actually see if the query is efficient or not here. And Bits Helper is the last one. It's been out for years, and Bits Helper supports a lot of features in Tabular, like you can see here to the right. And I will show you here. If you install it on your own laptop, where you have the development environment here, and you go here to Solution Explorer, and you can right-click there, and then you can see a lot of things that can be added here. We talked about display folders. Display folders are part of SSA as multidimensional, not always used, but if you have a lot of measures, you can organize them into display folders. And to use that as well in DAX, you can actually use Bits Helper to create them here. There is a little bit, there is an issue with the display folders here, because if you do structural changes to the tabular model, they might go away. But you can check that on Codeplex and try. But they have mentioned that as a bug here. And there are some reports as well that you can use while running your project here. Okay? So let's go back to the presentation here. Now, this is the final part and more tiresome part here. It's DAX to MDX conversion. So you will have that this in the presentation. I have looked at the most common scenarios here. We actually did this in the project as well. So what you see here is the obvious or simple ones. I have not formatted them that good, but I hope you can see them anyway here. So on the right side, you have the MDX ones. You have month to date, quarter to date, year to date. And on the left side, you have the equivalent in DAX. And I think they are quite clear in DAX. It's the measure in the fact table that you get here. The thing is that I have mixed. You can actually both write the sum function here. This is the occasion when you try to, if you use the basic measure in DAX that are not summarized, then you have to use sum here. But if you have done the calculation before with a sum, you can actually use that sum here, like you can see in the last example. So, and the other one, on the other part here, you actually you point to the order date table and the full date alternate key. So I don't think this is that difficult. Anyone with another view or opinion? Oh. So, accumulation over years. How do you do that? A running total from the beginning of the time dimension. Well, in the MDX, you can see to the right here, sum from start, I call that measure. And you can actually navigate down the hierarchy, pick the first member of the first parent, and have that as a marker, and then you go to the next. You actually use the current member function, where you actually stand. So, and that will work dynamically, like magic. I think there are 2 other ways to do it as well, but this is one way to do it. And in DAX, you will have to write a little bit more. You will have to use the dates between function here to help you. But it starts, as the previous example, first with a measure here. This is already sum calculated here. And then it's dates between, order date, full date, alternate key, blank. That's because the first one is blank here. And the last date, order date, full date, alternate key. And you actually have to add the all function here as well to make it work. So it's only to accept it. This is how you can do it. It's the only way to do it. Maybe they will do something, improvements in future releases, I don't know. This one is a little bit more tricky. It's actually parallel period. Parallel period in MDX is that if you stand on a single month, like now we have March 2015, and you want to go to March 2014, use the parallel period function. It will go back, get that measure, so you can compare March last year to March this year. Yeah, pretty obvious. The problem is here that DAX has a parallel period function that is not parallel period. It will accumulate the entire previous year. So this is, a trap, I would say. It does not do what it says, and a mix of using the wrong function name here actually. So what you have to do when use instead is same period last year function. That is the equivalent of using the parallel MDX function here. So these are the more tricky scenarios. Last periods in MDX was a useful function that we found. You can actually go, in this case, you can go 6 months back. And you can do that over years. So just give me the last 6 months over years. It does not stop with a year. And to find to do the same thing in DAX, you need to write a lot of code, like you can see here. Actually, Marco and Alberto was here having a look at it, and they said also that this is the only way to do it. So some people say that DAX is always more simple than MDX. I think this is a clear example that it's not always more simple. So the only thing is to actually to understand what's going on. Here is the famous calculate DAX function that you use to get more dynamics into your calculations and join different functions and make them work. And I think they actually should have a last periods function in DAX as well, because this is too much to debug and take care of. And then the little beauty at the end here, the distinct count. If you want to see the distinct customer, you actually go down to the fact table. Since I'm in the fact table doing this calculation, I don't have to mention the fact table here. So I can actually just point to the customer key like this. And this is really easy. Yeah. And this one was added in 2012 version of Power Pivot and DAX and Tabular. Before that, you had to a little bit more complex. You had to use a little bit more complex function here. So you calculate that in the fact table, and it will work. It will perform like magic. It's really good. Okay. Conclusions. Any questions this far? So we are gone from having, studied the different parts of the multidimensional model. We had a decision point where we had to decide whether we could move it over to multidimensional or not, and that was okay in this case. And we actually had a look then at the security, how you do it in Tabular. And at last, we had a look here at time calculation or time intelligence in DAX versus what you have in multidimensional. So it's impossible to move them, but some calculations are a little bit more trickier than others. You saw the obvious ones, and you saw the little bit trickier ones here. Okay? So my conclusions then, after running this project. Having a look, this new guy, that he has never done a tabular model before. He actually succeeded. He called me 2, 3, 4 times each day, and then he started to work on his own. I showed him over, not Link, another software, how to do it. So we exchanged screens all the time, and that was a good way to work with it. So he actually had his model up and working within 1 to 2 weeks after we started. And in this model, there are a lot of tables. There are, I think, something like 50, 60 tables, something like that. So it's not the most easiest task for a rookie to start with, but he succeeded. He was good. DAX can be simplified, like you have seen here at the end. Smaller models load faster and might have. There's no guarantee, because you can actually build bad models in Tabular as well. So, but usually, because they are allocated in memory, they should be faster. Yeah. Multidimensional, on the other hand, is good when you have very large models, like 50, 100 gigabyte compressed data. That's because you don't have to load everything into the memory of the server. If you have complex security roles or you have complex calculation logic, you should let it stay in multidimensional, see what happens with the development of Tabular in the future releases, and see if you can move it. But multidimensional will stay here and will work for a lot of years to come. And if you have a lot of calculated measures or in the multidimensional model, it takes too long time to write them in Tabular. I had 300 measures, calculated measures in the hotel application. 300 measures. It took around 2 days, something like that. Because the editor actually, if something is wrong, a little bit is wrong in the DAX that you enter, it will just throw away everything. You'll have to start from scratch. So, this is a repetition, more or less. We'll stay with multidimensional. Yeah. And resources. The book I've used, it was the book written here by Marco, Alberto, and Chris. You have DAX formulas for Power Pivot. Rob Colley, he's more focused on Power Pivot. The difference between Power Pivot and Tabular is that Power Pivot do not have security. You have access to everything in a Power Pivot model if you deploy it on SharePoint. You don't have translations. No, you don't have partitions, and you don't have perspectives in Power Pivot, but you have it in Tabular. And but Rob's book is good as a complementary book to Chris Webb's and Alberto and Marcus' book. Microsoft Tabular Modeling Cookbook from Paul Tebruck is also very good. Recommend that as well. It's more concrete, direct tips to do this. How do you do this? How do you do that? So it's more focused on results, direct results, I think. And then you have two sites. Marcus and Alberto's sites is SQLBI.org. PowerPivotPro.com is Rob's site, and he publishes a lot of good blog stuff there. And the last one, DAX Patterns, is also Marcos and Alberto's. You can find a lot of information there about time calculations and things like that, how to do them. They really go through different scenarios. You can actually, they have actually created a book based on that site. So, it's 36 now. Anyone who has some questions? Will you go home now and move all your multidimensional to? No, you shouldn't. I have some additional small facts here. When all of you that have done some tabular project, what do you think about the Workspace database? That's a copy database, tabular database, that gets created when you start the project. And the thing is that you don't know. I was very unsure of whether my changes were published to the Workspace database or to the production, but they are automatically published to the Workspace database. And you can place that Workspace database on your laptop if you want. It will actually not download all data, it will download a selection of the data. So it will not stress your laptop too much. But when you deploy, you always deploy it to to your production or development server. The thing is that if you look in Management Studio when you have data tools open, you will actually see a copy of the Workspace database if you have placed it on the server. It will be there with a long, unique identifier at the end. Yeah. Okay. This was my presentation so far. If anyone of you have any questions, please come up and I will try to answer them. Thank you very much.